Hello everyone. Today I'll be discussing the 7 functional groups and their properties. So what are functional groups? Functional groups are the parts of a molecule that are involved in any chemical reaction. They are a chemically reactive group of atoms located within an organic molecule. The functional groups determine the chemical properties of the organic molecule it is bonded to. Now for the 7 functional groups. There is methyl, hydroxyl, carbonyl, carboxyl, amino, phosphate, and sulfhydryl. Let's first review methyl. As shown on this diagram, methyl consists of a carbon atom bonded to 3 other hydrogen atoms and 1 R group. This R group, which is shown in the following diagrams as well, represents the molecule the functional group is bonded to. Methyl is part of the compound known as the methylated compounds. It is a nonpolar substance and affects the expression of DNA when it is indirectly or directly bonded to it. Here is an example of methyl within an organic molecule. Pause the video and try locating where methyl is. Methyl is right here with the formula CH3. Now for hydroxyl. Hydroxyl consists of an oxygen atom bonded to a hydrogen atom and a reactant group R. It is a part of the compounds known as alcohols. Hydroxyl is polar. Due to its polarity, hydroxyl can make the molecules it is bonded to water-soluble. This is possible because, as previously explained, functional groups determine the chemical properties of the organic molecule it is bonded to. Besides making molecules water-soluble, hydroxyl also extends its chemical properties and makes the entire molecule it is bonded to into an alcohol. Here's an example of hydroxyl within an organic molecule. Pause the video and try locating where hydroxyl is. Hydroxyl is right here with the formula OH. Carbonyl is another functional group. It consists of a carbon atom double bonded to an oxygen atom and the same carbon atom single bonded to 2 other reactant groups. Carbonyl tends to be bonded to 2 reactant groups because carbon has 4 valence electrons. As a result, it tends to form 4 covalent bonds, as shown in this diagram. It is double bonded to an oxygen atom, allowing the carbon atom to form 2 other bonds. Carbonyl is part of 2 compounds known as ketones and aldehydes. The difference between ketones and aldehydes is that in ketones, the carbonyl group is found within the carbon skeleton of the molecule, while in aldehydes, the carbonyl group is found at the end of the carbon skeleton of the organic molecule. Carbonyl is also polar, so it can make the molecules it is bonded to water-soluble. In this example, pause the video and find where carbonyl is located. Carbonyl is right here with the formula CO. Here, carbonyl is presented as an aldehyde since it is found at the end of the carbon skeleton. Now for carboxyl. In carboxyl, a carbon atom is double bonded to an oxygen atom. It is also single bonded to another oxygen atom that is bonded to a hydrogen atom. That same carbon atom is bonded to 1 reactant group, totaling 4 total bonds made by carbon. Carboxyl is a part of the compounds known as carboxylic acids, which are also referred to as organic acids. The reason carboxyl is considered acidic is that when it ionizes, it can release hydrogen ions and become negatively charged. If you recall, a solution becomes more acidic as its hydrogen ion concentration increases. Since carboxyl has the ability of releasing hydrogen ions, it is considered acidic. Now pause the video and try to find carboxyl in this example. Carboxyl is right here with the formula COOH. Now let's review amino. Amino is a functional group in which nitrogen is bonded to 2 hydrogens and 1 reactant group, totaling 3 bonds. It is a part of the compounds known as amines, and similar to carboxyl, it can become charged. Amino groups can accept hydrogen ions to form NH3+, also known as ammonia. Since amino groups can remove hydrogen ions from a solution, they are considered basic. In this organic molecule, pause the video and try to locate the amino group. Here is amino with the formula NH2. Phosphates are the 6th functional group. It consists of a phosphorus being the central atom, which is double bonded to an oxygen atom, single bonded to another oxygen atom which is bonded to a hydrogen atom, single bonded to another oxygen atom which is also bonded to a hydrogen atom, and finally, single bonded to an oxygen atom which is bonded to the reactant group. Phosphate is part of the compounds known as organic phosphates, and like the previous 2 groups, phosphate is also a charged molecule. It ionizes in order to release hydrogen ions. Similar to carboxyl, phosphate is considered acidic, since it can donate hydrogen ions to a solution. Try locating phosphate in this organic molecule. Here is phosphate, and as you can see, rather than being bonded to two hydroxide molecules, the phosphorus atom is bonded to two negatively charged oxygen ions. Finally, sulfhydryl is the last functional group. Sulfhydryl is a part of the compounds known as thiols. It is a polar group, so as a result, the organic molecule it is bonded to also becomes polar. Sulfhydryl is generally found in certain amino acids and proteins, determining the role of the proteins it is bonded to. Try locating sulfhydryl in this organic molecule. It is right here with the formula SH. That's it today for functional groups. Remember that functional groups determine the properties of the molecule it is bonded to, so when you're trying to determine what a certain molecule does, just see if it has a functional group, and if so, which one is it bonded to. Thank you for listening and have a good day.